Good afternoon to this Introduction to Drones CPD session. It's being run by ARPAS-UK, the Drone Trade Association, in conjunction with Connected Places Catapult. We're delighted to have you all here, and thank you very much for signing up to the CPD sessions and joining us. Michael May of FlyThru will be leading today's session. He has extensive experience of flying drones and also flying within general aviation too. We're delighted that he's able to do this and hope that you will benefit greatly from his experience too. Michael is an experienced entrepreneur and qualified pilot, and he runs a company that offers 3D mapping, thermal imagery and LiDAR, providing aerial data in a cost-effective and safe fashion. Just a couple of quick housekeeping points. As you notice, we are going to be recording today so that you can have access to this afterwards on the ARPAS UK website. So please, as a result, keep your cameras off and stay on mute. If you have any questions, and I'm sure there will be plenty, please do pop them into the Q&A box. Afterwards, if you want to get in touch with us, the easiest way to get in touch with me is via email on membership@arpas.uk, ARPAS.uk. And Michael's email is michael@flythru, which is FLYTHRU.co.uk. Thanks very much. Over to you, Michael. Thank you very much.
No problem. Good afternoon to all of you, although I can't see you. And we're getting used to doing everything virtually now. Only housekeeping from my end. If there are any fire alarms, I'll be very surprised in my dining room. And the only thing to look out for are Amazon and an over-exuberant Labrador. So hopefully we'll get through today and give you an idea of a good introduction to drones of all types, sizes and shapes, the data that we acquire from them, and give you some real live examples of what we do in the world of flying and obtaining aerial data. Hopefully it won't be too much of a death by PowerPoint session. You know, we're going to be running for 45 minutes, an hour or so. Any questions, please address them via the normal routes, and hopefully you'll find today interesting. What are we going to cover? What are drones? You know, what is UAVs, ARPASes, amazing number of acronyms that are out there that describe what we have and what we fly and what we float and what we have submerged to obtain data on behalf of our clients. I think the biggest factor that we all need to take into consideration, it's not about the drone, it's about the data it collects. And no point having something very flashy if the client at the end of the day can't do anything with the data, or the data is not as useful as they thought it might be. We're going to describe how we use them, and I'll give you real life examples of the types of scenarios that we have been involved in. There are many others, and hopefully I'll try and remember some of them to tell you about as we go through, and then just a summary and any questions that you might have of myself or of the guys at ARPAS, so we can direct you in the right way. If there's anything too technical, I'll get back to you. Hopefully I should be able to answer most of the questions that come up based on the questions we've had so far. So a little bit about us. We've now been running since 2013. Just to give context, in the drone world, there were more people that had gone into space than had a drone operator's license, whatever it was called at the time when we first started. That's now changed. There are tens of thousands of people who have been through various types of courses. The Civil Aviation Authority adoption of drones and the legislation around them has changed dramatically over that period. And so is the technology that is being used, so is the safety surrounding that technology, so has been the adoption of industry and professionals around that as well. So that gives a little bit of context of what's happened over the last 9 years. The first drones that we flew, most of them were put together by Ben, who's actually in the picture on the bottom right hand side there. carrying a GoPro on a 2-axis gimbal, so a 12 megapixel camera being flown for about 5 or 6 minutes. That's what we used to get. And when we'll talk about the other types of drones that we fly now, there's a heck of a difference in what's commercially available. We have all of our pilots have been through 3-day courses, which was the norm in the original day, learning not only about how to the legislation surrounding how we can operate and operate safely and within the law, but also giving us ground training on the flight of the different types of drones, whether they're fixed wing or multi-rotor systems. Between us, we've got over 30 years flying experience, whether that's, it's now called occupied aviation, planes and helicopters to you and I. And we've operated all over Europe. We've been very, very lucky to be operating over in Finland and Norway and the Channel Islands, France, Italy, Croatia, all sorts of varied jobs that we've done over there. And adopt this, I think I'm going to say it so many times today, and not about the drone philosophy. Find out what the client wants, find out what they want to see, find out what they want to use the data for, and hopefully find a solution for them. Sometimes it's about putting a camera on the end of a stick, because it's far more practical and safe to do so than flying a drone adjacent to maybe a busy road when you haven't got the experience necessary to be flying there. What are drones? Well, what are they? They are remotely controlled unmanned aerial vehicles. That's what we're going to talk about today. They are what you used to see in Maplins, now see in Currys, the little toys that are being flown around, as well as the larger scale versions that I'm going to show you and how we've used those. They are controlled in the commercial world under what is now called an operational authority, which is granted by the Civil Aviation Authority. That has changed from a permission for commercial operations, as it used to be known, but it's basically your license as a commercial operator to have proven that you are sound of health, that you have passed the relevant exams to understand legislation, and in some cases passed flight examinations as well to prove that you're competent and safe as a pilot. We're going to talk about the payloads that the drones carry and how we use those payloads, which I think is more relevant than this is a camera, and the restrictions that are initially placed on commercial operators. So if you were to pass your commercial license, obtain an operational authority, so you've written your manual of operation and and the Civil Aviation Authority are happy with it, and they've granted you an operational authority, they normally say that you are allowed to fly to a height of 400 feet or 122 meters if you can still see the drone. So is it in your line of sight? If you can't see it, you're not allowed to fly that high. You are only going to be able to fly what's known as VLOS, visual line of sight, at all times. So you're going to be able to see the drone. The smaller they are, the further away they get, you're not going to be able to see them, some of them at that height. And the distance away from you, linear, so you stand in the middle of a circle, 500 meters away. So in theory, you could be 400 feet high, 500 meters away. I can guarantee that some of the drones that you are able to buy commercially now out there, you will not be able to see. If you can't see it, you're not allowed to fly that far away. Just because it says in your license you can, you cannot. You must be able to see the drone at all times. There are exceptions to that. And when people have operated and for a number of years, as we have, we're granted and we've proven with an operational safety case, we're able to operate further away with the larger drones that we're still able to see and have observers that are assisting the pilot, and also nearer to people that are uninvolved. So we've proved that we can fly in and around people. We've proved we're competent. We've proved that we can brief people and give them notice that we are out and about. And then we're able to fly nearer. That's on an individual basis and assessed by the Civil Aviation Authority. Obviously, if you're going to be out there using a drone to do inspection work and you're inside, There is no limit to what you can do apart from your normal health and safety risk assessments. There is no restriction of flying inside, and there's no, obviously, underground is exactly the same. The Civil Aviation Authority do not own that airspace, that is privately owned. So what do we use? We use a variety of multi-rotor and fixed-wing drones. This is our, I suppose, hardest worked UAV at the moment. It's the DJI M300. It's able to carry 3 payloads at once, including a lighting rig. We carry 2 cameras and a lighting rig normally. So we're taking a wide angle, a close up, and a thermal image 30 times per second using this this system. I think I mentioned before that when we were flying the original drones with 3, 4, 5, 6 minutes with a 12 megapixel camera. This, as a norm, carries a 42 megapixel camera and will stay in the air in reasonably stable conditions. I'm thinking about wind, for around about 40 to 45 minutes with those payloads on board. And with a LiDAR system, a laser system that we carry as well, about 35 minutes. So you can imagine the 2 things that you've got to factor in. Firstly, how tired you get flying these things, and hopefully, keeping an eye on them in the sky, compared with when you were only flying them for 6, 7, or 8 minutes. There is that period in a flight where you get a little bit blasé and say, well, it's still up there, I'm sure it is, and you then realize you have to switch on quite quickly because you've taken your eye off the ball a little bit, and observers are saying, well, there's a plane over there and a helicopter over there. It has got its issues, but the quantity of data that can be collected in a 45-minute flight, if you're looking at photogrammetry, and a lot of the work we do is collation of multiple images and creating what is really an Uber Google Earth in 3D, you can be upwards of 15 gigabytes of data in a single flight. So it has its issues in regard to checking it, putting it on computers, uploading it, downloading it, showing it to clients. It has all changed dramatically over the last 6 or 7 years. The other system we use is fixed wing. So a big plane, if you like, that is 2.8 meters across. So it takes a little bit more consideration in terms of where you're going to take off and land. It's a hand-launched system. Carries a Sony 42 megapixel SLR camera, A7R, used for doing large area mapping. Now, if you consider that this, with 2 batteries in it, will stay in the air for over an hour and a half, it will cover a distance of over 300 kilometers. Obviously, we're not flying in a straight line. We're never doing 300 kilometers. We are flying ups and downs, normally in 500-meter swathes, carrying the camera, doing overlapping imagery. And we use this a lot for doing mapping in and around the roads and rail network. It has twin motors, so if one of the motors fails, it's not going to fall straight out of the sky. If both motors fail, we're able to glide it away from any structure or persons or traffic. So that's why we use that type of drone. People think of drones as being the multi-rotor things, but probably more like that one there. That's a Phantom RTK. So this is one of the systems that we use for mapping. The difference being it has not as good a camera as the large system, and it's only able to stay in the air for about 20-25 minutes. So you have to go lower and slower to get the same type of data as you do with the more expensive and larger platforms, which are a little bit harder to fly. But it's horses for courses. We've absolutely used these to, I was going to say to death, nearly to extinction, because they're a fantastic tool. They work really well. You've got probably about £3,500 sat in that, as compared with somewhere north of £22,000 in the larger rig. And then finally, we use another M600 and the M300, both DJI large framed multi-rotors to carry out our LiDAR systems. We have 2 LiDAR systems. LiDAR is light imaging detection and ranging. So if you, everybody thinks it's laser, because it uses a laser, laser is only a beam of light. That's what it stands for. So this is used to collate information in 3D through and of vegetation, and I'll give you some illustrations of how we use those and what we use. But again, you know, you're carrying 4-5 kilograms underneath a UAV and transmitting back to a base station, staying in the air for 24-25 minutes. Other remote sensors, just think about, you know, how we're not just flying things now. We use buggies. On the left hand side, we use handheld laser scanners. We strap those and put mounts onto boats. We put mounts onto all sorts of things in order to go and get data safely. It's 99% led by the client's wishes. We would like to have that 3-dimensional model of the inside of that pipe. How are we going to do it? Sometimes you can't get a drone in, it's too small. Sometimes it's too rocky or wet to put the buggy in. And we'll then have to put a boat in, and what camera are we going to use on a boat? We've actually fixed one of the drones, because the camera was so good, onto a boat, a remote control boat, and put it underneath a bridge where it was impossible to fly. We did that because there was a consistency with the camera that was used. We trained the bridge engineer on the use of the camera and being able to manipulate it whilst it was flying, so he was able to do it while we're on a boat. We just positioned the boat where we would have positioned a flying aircraft, but then they get a consistency of data, they understand how to use it, and they get what they want. We have, as I said right at the beginning, I've put a camera on the end of a pole and stuck it over the edge of a bridge because it was the safest thing to do. The client got the data, they're really happy with what they get. So why do we use them? Well, they supplement and in some ways enhance and replace some of the conventional techniques that we've used. It increases safety. You know, I think everybody gets stuck on risk assessments, and they become the thing that we write so we can go and do a job. And the purpose really of a risk assessment is to say, why are we doing that in the first place? Why are we putting ladders up when we don't need to put a ladder up? Why are we putting scaffold there when we don't need to? Why am I putting a person in a road with a stop go sign when I don't need to? And I think that's in all industry now. We send risk assessments on every single job that we do, and method statements. And I think it gets lost in transition. The whole reason that you do those is, do we really need to do that to get this? That's the first question that should be asked. And removing a human element removes a risk. And I think that's what we're seeing now in this industry and other remote sensing techniques, is the ability for anybody to remove that risk and obtain better data, obtain it in a more timely fashion, and in a lot of ways more cost effectively. So if you can tick the box and say we can do all of those things, then you understand why the large organizations are taking this very, very seriously and are backing the use of remote sensing. So the type of data that we collect, and this is not limited. I was talking to Eleanor before we came on the call about another advancement that's being made at the moment. But photography, originally it was lovely pictures for estate agents of houses and buildings, and you're never going to get that view from anywhere else. And as I've said on all of the calls now, there's even drones used on the Great British Bake Off, taking pictures of the tent. So they use so much in video and TV in the media world. There is no way that some of the shots that can be taken with with UAVs would have been able to be taken with helicopters. The disturbance to the ground is absolutely ridiculous. And thinking of the forensic work that we do, you know, now we're able to hover over a scene of a crime at 2 meters without disturbing any of the fibers that are on the ground, and be able to take imagery that was never used ever before. We've mapped disaster scenes and taken that data using both video and photography and overlapping imagery that is there forever now. It records, and it is now, instead of being a ground drawing or one video from one angle, or a video from a pole, or from high up on a helicopter, or from even Google Earth, you're able to create the bespoke imagery using drones. Now, having said that, apart from the photographs that are used for our mapping and 3D data collection, we do very, very little in terms of photography and videography, unless it's for inspection work. We use thermal and multispectral imagery at the same time and in conjunction with videography that we may take, so that not only are you getting a thermal picture like we've seen and like is in the bottom of this image here. This was a solar array just showing that basically they need to cut the grass because it's causing shadowing on the panels, and therefore they're not as efficient as they should be. The picture in the top is not actually a photograph. That is what's called an orthomosaic. So that is a knitting together of hundreds of images to create a 3-dimensional model, which can be used then to measure from and to create drawings. We do a lot of LiDAR work. I think I've already explained that. I'll give you some ideas of how that's worked, and even underwater sonar work. So it just gives you an idea of the type of data that we collect, and again, all driven by the need for our clients. The LiDAR work was driven by the police requesting us to search for a clandestine burial site in Yorkshire, where an honour killing had taken place. Well, a murder, but wrapped up as an honour killing with a family, and they couldn't find, by sending in the guys on the ground, what they were looking for through vegetation, and we were asked to go and use a LiDAR system to try and help them locate the grave, which we did. So there's a heck of a lot of ways in which this data can be used. The majority of our stuff is either in construction, in and around, apart from the forensic work that we do. So it might be planning, it might be pre-construction, it might be post-construction and monitoring, and inspection work, down the line. A lot of the work that we do to inspect structures is part of a 6-year rolling program of primary inspections for bridges that overpass over roads or rail. So they have to be done. There's a CAD drawing at best of the structure. There's nothing underwater. They've no idea what is under there. And quite often the bridge has been added to, strengthened over the period of time, because it has to take a higher load. And there is no one data set that captures the structure itself, and that's when we use UAVs, drones, laser scanning, all sorts of different types of methods to collate that data in one place for interrogation at any point 6 years down the line. So I'll move on to some examples of the type of work that we've done. There is a little video that will go after this, but this is a proposed cycleway from Connell to Dunbeg. Those who don't know the area, Oban is around the corner in sunny Scotland, and this is an area that was vastly overgrown with trees. There are parts of it that are tidal, parts of it over houses, and we were asked to do a photogrammetry and LiDAR mission over this area. There is a little video, as I said, that shows the type of area we were in. It's a little bit commercial in so much it was the manufacturer of the system we were using at the time made it, so I'm making no apologies for that, but it gives you an idea of the type of area that we were in and what we were doing.
So FlyThru started 6 years ago. Ben, my business partner, was a hobbyist, and I'd flown light aircraft and helicopters.
At the moment, we're working on a project for a cycleway, which is linking two existing cycle routes.
And we are going to assist the council by creating a digital service model using the LiDAR system. LiDAR has given us another string to our bow. It's another mapping technique that complements photogrammetry and in some cases actually replaces it. It's probably grown our business by 50%. The LiDAR pod has been great for us in terms of its penetration of vegetation. 90% of the work that we get is about the data that can be acquired in difficult to reach, heavily vegetated areas. I think that we were surprised at the amount of points per square metre that we were achieving through dense vegetation, not just in winter but in summer.
The support along the way has been fantastic. Any on-site problems that we've had, technical or hardware related, we've been able to speak to a technical assistant very quickly on the phone.
I won't go into any more of that, but it gives you an idea of the, we're deploying out of gates from, for farmers' fields. We're able to fly safely in and around livestock. We're able to create maps that weren't ever able to be seen before. There's no way there was a contour that we created of meter intervals. In fact, we went down to 50 centimeter intervals, which actually took in the rock structure that was at low tide. So those maps and information had never been there before. So it gives you an idea of the type of work that in that pre-construction and planning phase that we went through. We're being asked more and more to look at the ecology and certainly in the world in which we are operating at the moment, the carbon footprint of everybody and the way in which we protect the environment is tantamount. Obviously, we're using battery and reusable, rechargeable energies. We are being asked all the time about how our carbon footprint is. What are we driving to site? Certain parts of the world, the Transport for London guys are now saying that they will only accept some of the construction guys working with electric vehicles and nothing else. But again, we're looking at the impact of construction on the environment. In this case, it was an area just outside Coventry that had been acquired by a construction company, and they wanted to build 300 houses on it. It had been left fallow for a while. It was an old pump station owned by the local water authority, and the local residents were up in arms saying, look, there's lots of nice trees on here. We don't want them cutting down. What can we do to preserve them? And to be honest, they had no idea of what they got and how they got it. So we were asked to use the LiDAR and photogrammetry system to record the trees that were over 9 centimeters in diameter. So these are ones that they thought were mature enough that we should be leaving them and showing where they might be, and therefore adjusting the planning application that had come in from the construction company. This was the site. If you can, you'll be able to look at this in your own time as well, but you can see on there that you've got lots of green and lots of black dots. All of the black dots that we recorded are trees that are over 9 centimeters in circumference. All of the green areas you can see from I don't know if you can see my mouse moving, but in that V there, down the edge of the road, and then in an avenue, which is I think what you call 2 rows of trees, you could see that there were mature trees there, the canopies of which you can see outlined in green. It was quite obvious that even if they took away the smaller or a number of the smaller trees, and that site was very heavily vegetated, and it was as a result of this, they've decided that they would leave it as a green space and wasn't going to be used to have any construction on. I don't think we were the construction company's best friends, but we provided that data, and the council were quite amazed about how much mature vegetation was on that piece of land, which had been only fallow for about 10 or 11 years. So it gives another perspective as to the type of work we do. Just a sip of water. The next one was another pre-construction task that we were given just outside Edinburgh, next to the River Almond. There's an existing cyclone walkway which was becoming quite dangerous in terms of where it was, built in the 20s, and nobody was really bothered about health and safety and handrails or people on mountain bikes trying to go down steps that they shouldn't have done. And they were deciding if they were going to create a new glass walkway, which they were going to attach to a rock face above the river. So we were working with surveyors, complementing their laser scanning and creating a 3-dimensional image of the area of land that they wanted to develop. So the week before this, we couldn't have actually gone in the river, but at this time we took 2 days doing laser scanning of the rock face you can see in the picture by moving simply moving the laser scanner down the center of the river and take the necessary image in 3D. At the same time, we were flying and we were recording LiDAR or laser light data, which we would then use in post to create a model where we'd extracted the vegetation and we could show the client exactly what they had underneath those trees that you can see primarily on the right-hand side of that picture. And when we'd finished it, we combined the 3 data sets from land and air, and we had 20 billion points of data. And this is where I hark back to right at the beginning. Knowing what the client wants and how they can handle it is absolutely imperative to not wasting your time, but not wasting the money of the client as well. The client in this case was the council, and they didn't have a computer in Edinburgh Council that could handle the data that we collected. And it meant that we had to take our computers, literally unplug them, take them up to Edinburgh and help modify the data into being readable formats and usable for the client. Everybody says they want it in the highest resolution and they want it in the most infinite detail. The problem is they can't handle it. And that is something that has to be borne in mind, thinking about drones and thinking about how you might use them. Can you handle the data? What do you want to see? How do you want to see it? If you look at the left-hand picture, and I don't know how much detail you'll be seeing, but you can, as I said, interrogate this afterwards. There are lots of green orbs with lines coming off them at the top of the left-hand picture. Each one of those dots represents the global position, a geolocated image, so a photograph that has been taken. Most of those photographs have 16 other points of reference, which helps us create a 3-dimensional model. So each of those, the software is identifying identical points in other images taken from other locations to build a 3D image. The image below is not a photograph, it's a series of stitched together photographs digitally. That's why you'll see the black voids in the water, because photographs, you imagine water is a moving item, and you never get a point of reference from water because it changes second by second. So there's never that same point. But obviously a tree, a path, even a vehicle sometimes, it is a static object and it's able to be seen in multiple photographs. So that was the photography, the orthomosaic, or if you think about it, a big tablecloth that you throw over a 3-dimensional point cloud. So you colorize the cloud that you take by taking multiple points and overlay that as a tablecloth of images to give you a 3-dimensional model. And on the right hand side is the LiDAR data that has been through post-process, and you can see that we've removed the vegetation down to, I think it was 30 centimeters on this model. And you can see there clearly the footpath that exists, the larger, wider, winding path at the top, which is the one that they're going to try and replace. And then there's another footpath that they weren't aware of that people are using and riding, which is just to the, let's go northeast of the big tract. And that was revealed through the dense tree coverage. And it gave them an idea of exactly what they were looking at from the air, and combine that with the stuff that was on the cliff face as well. Hopefully these are real world examples, and give you an idea of the type of data that we collect and why we do it. If you've driven up from the south to the north, taking the M11 or A1, you'll have driven past the A14 link road at Swavesey Junction, where they've been, think about it, from Cambridge up to Huntingdon, basically modifying the road to being the fantastic road that it is at the moment. And we were asked by the guys who are moving vast quantities of earth from borrow pits, so they were digging out kilometre square pits to get to the clay to use in construction in other parts of the site, and then where they were digging other parts of sites, filling back in. And we were asked to, on a monthly basis, do a flight over this 750 hectare site, which we managed to do in a single day in the summer, using the twin motored fixed wing that I showed you earlier, and we'll show a little video of it. The interesting thing was that we had to work around a construction site. So there's challenges. The first time you use it, everybody's going, oh, it's a drone, it's a drone. By the time we were using it, third or fourth visit, all the construction guys were completely au fait with what we needed, how we do it. Some of them even scraped off some soil for a landing site for us. But we are working around, because we're talking to excuse me, and providing information to the guys we're working with. We've got two large excavators there, multiple small tippers. We've got the A14 to the right-hand side, which is operational, and a crane. And we're able to work in and around them. You'll see from sort of center left of the crane, the plane coming into land. It's only when somebody's videoing that he takes that long to land. Normally lands it a lot shorter than that. But it gives you an idea of, you've not got a multi-rotor that you can just put on a sixpence. We've got a completely different kettle of fish, and being able to operate in and around construction workers without any problem whatsoever. So what we did was we provide a digital surface model, and you can see on the image there that we have various, what you can see is, I'm going to call them mounds and cutouts. So you've got trenches, and you've got stockpiles. And the volumetric analysis that was performed by the surveyors meant that they knew exactly how much earth they have got to move from point A to point B in order not only to do the job, but to satisfy the requirements of the planning restraints, so that they were taking back, either enhancing the environment and making sure there was some beautiful green areas that had been probably left fallow before, and that the land that had been compulsory purchased or compulsory borrowed in some states from the farmers was returned to a workable field. But it saved the earth moving company over £1 million over the 2 years that we were there, in being able to accurately quantify in a day the amount of earth that they had to move from A to B. And that was purely in fuel and off-hire cost that had been estimated previously by using a QS saying we've got to move that there and we've got to move it here, there and everywhere. But by doing that on a monthly basis and paying us, they were able to save over £1 million just in that one period of construction. So that gives you an idea when we're constructing stuff. Once it's constructed, we've got to inspect it, and people are this part of the A11 was built. This bridge was built, and when they'd completed it, they realised they'd sold all the land around it, and they couldn't access it in any way. There's a fence that has been built to the south. You can see a little green line running across the bottom of the picture there, and that's now actually a housing estate. To the north is completely fenced off, and originally they were planning to inspect this on a 6-yearly basis using mutes, going in underneath and checking on the state of the concrete, and also the bearings that are taking the load of the bridge. They're not able to do it now because they've sold the land in and around it. So what we do is put the drone in there. Now these two images are taken from 5 meters away. They're simultaneously captured. One's the wide angle, one is the more zoomed, but it hasn't been zoomed in at all. Those are the images that we give, or actually were taken by the bridge engineers. They then zoom in on their laptops back in the office, or they've got the option of using 100 times plus digital zoom on site to be able to capture the detail of the corrosion in and around those bridge structures. There is no other way, apart from putting a very long pole with a camera on the top of it that you're not going to be able to see, of capturing that data. And we are able to look at the 17 bearings underneath that within an hour, which has saved this is Essex County Council, handed back £200,000 to, Essex Highways handed back £200,000 to the council because they didn't need the higher cost, they didn't need the person cost to be able to do the inspections. Now what they've done is, instead of using that money elsewhere, they've increased the amount of structures that they actually inspect in a year, just to make sure they maintain that safety. Bridge in the middle of Colchester had a very fast flowing river underneath it, couldn't get into it with boats at low tide because it was silted up and the silt was too deep to walk through. At high tide, the river was too high to get anything underneath other than a drone. So the honesty is, it had never been inspected underneath, and now it has. And one of the things we were asked to inspect was some of the edges of the parapets, where we were using a simultaneously captured thermal and standard image, and were able to identify some water ingress. When you went straight up in a straight line from that picture, you could see that there was a bad repair that had been done of the footpath, and it was just a very, very simple way of saying, what's that? There's a line there, walking onto the bridge parapet. No traffic management in place. Nobody had to be disturbed. Nobody in the road, maintaining the safety of people. So, well, that's your problem. Marker on it, and we're able to replace that small patch by just taking that image, which took seconds. And finally, I suppose, you know, this when we talked about bridges, some of them are built in the early part of the 20th century, the late 19th century, and have been modified beyond all belief just to take traffic. Some of them are tidal, and some of them have the effects of that tidal range on the scour, and on the pillars that have been sunk into the mud and silt. And putting a diver in there is great, but a diver can't see anything if the water is mucky. And obviously there's a cost and that safety implication of putting a diver in the water. So we use an underwater sonar camera, laser scanning, photography, photogrammetry and LiDAR to build 3-dimensional images of the bridge, both above and below water. So remote sensing being used at its maxima there. And the final example is how we've come so much further in the last 6 or 7 years. Now we're able to produce drones that go in a cage. that are able to flown into confined spaces where really you don't need to be or want to put people. This is, as you can probably see from the far right hand corner, those are the White Cliffs of Dover. I say Dover, this is Folkestone. There are 19 of these drainage adits underneath the railway there, and bearing in mind that railway is the main carriageway from the UK over to France, going through the tunnel. There's a slippage on this land, and they wanted to have a look at the state of the drainage adits and look at their condition. So we, over a week's period, we did all 19 of the adits, and we pumped out the water first to obviously create a drier environment. But this gives you an example in real time of how quickly we can identify faults. Excuse me. It's not just pilot error, these are horrendous to fly. There's no GPS stability on them. And obviously we're in a GPS denied environment. These were 1950s and 60s remediation works that have been done in these adits. And we're able to show the condition by simply flying down the tunnel. You'll see as we come fairly quickly to a slight bend round to the left, only because I've seen this video a number of times. The height of this was about a metre. So it starts to go around to the left. People, you can see the condition of any of the walls. Then it starts to be some sort of build up in the base of the adit. And we come to a collapse and a failure and a blockage. So that's real time. That's 1 minute, 12 seconds to get that data that you can't get in any other way. And obviously taking out the human element of risk. And capturing 30 frames per second all the way through that, the engineers are able to go back to the client and say, this is what we've got, and these are our recommendations. And this is combining the whole thing. If you look from the, I don't know if you can see my mouse being moved, but from left to right there, that's the railway line that's going underneath the channel. These are the White Cliffs of Dover. That there is the World War II Battle of Britain Memorial, and we're down here somewhere. So this is LiDAR, photogrammetry, a little bit of Google Earth, laser scanning, and video sets that we have combined. And it's not going to run, is it? Try again. No. Never mind. Well, Elena will upload this later. I'm sincerely sorry about that. It's the one that's failed. But it just shows how we combine data sets into one large file that is able to be collated and shown to a client to give them a fantastic view of what we did. Unfortunately, it doesn't want to work just now. My apologies. So there you go. I hope that's given you an insight into how we practically use drones and what sort of data we collate and why we collate it. There are so many more ways in which we work with drones. Only yesterday I was at the research facility at the University of Sheffield, where we're looking at automating what is hammer testing for the test. At the moment, a guy or girl with a hammer goes and tap tests concrete structures to listen for voids and to try and detect any problems with the corrosion of rebar or reinforcement of the concrete. And we're looking at how we automate that process by putting a sonic system onto a drone and a hammer, which is a little tap tester, to be able to record the sound waves to automate that process and be able to eventually automate a flight plan with a drone pushing against a structure and making a small tap test to record that type of data. So it's amazing the type of things that are being done. And this was a research student that was given a 12-month project, and in 6 months he's already used our systems and our pilots to help him develop what could be a very sound commercial product. Got to remember the complementary as well as enhancing normal techniques. Industry is becoming aware, and loads of the larger organisations have their own drone teams and use us for the specialist side of things. Not to be taken in isolation. Don't do it as a replacement. You know, think about the type of data that needs to be required and the way in which you'd want to fly it. But that's me. That's the end. If there's anything that you would like to ask, I'm very happy to take any questions. And if not, you'll be able to contact me afterwards. And if you'd rather do it through the other channels, then that's absolutely fine. But Eleanor, if there's anything I can answer now, I'll try to.
Excellent, Michael. That's very kind offer, because we do have some questions. So the very first one is, thanks, Michael. Some very interesting projects, including the tunnel drone. How does anyone interested in training become a proficient drone operator?
How do you become proficient is just about practice. It's the same, exactly the same as driving test. You go, you do your revision, you do your theory, you fly the drone, you get your exam. But in order to become proficient, it's a matter of time on the sticks and practice and working around professionals who know exactly what they're doing. I think Eleanor will give you an idea of who to contact, because it's important to make sure that you are going to go and be trained by competent and qualified personnel. I'm going to throw my 3 pennies in and say, if they offer a course where they assess your flying, go and do that. Don't just do something online. It really does make a difference. It also makes a difference to see if you actually can do it and you like doing it. You don't want to be going to do something that you don't want to do and you find very difficult and stressful. But Eleanor will sort of pick up off what I've just said, I think.
Indeed, and actually I've put it into the chat. There is a list available on the ARPAS website of our members, obviously, who are qualified to teach you. Whole of the UK, and we'll teach you in a variety of different formats. So really, whatever sort of suits you, works around you. If you have any questions, do get in touch about that. So the next question is very interesting one. Are there any public places here in the UK where we can fly a small lightweight drone without permission for training purposes only, i.e. not commercial? And how can we know whether it is legal or not, i.e. permission not required to fly over a certain area?
Ooh, now you are. CAA, sorry. You have certain restrictions on you in order to fly. So you're not allowed to go within 50 meters of people or uninvolved persons. So what you want to be doing, if you can go to, unless there is specifically a signage in a public space saying you can't fly drones, so there is a local bylaw, and there are lots of local bylaws in and around London, especially saying drones are not permitted to be flown. As long as you're in an open space and give yourself 50 meters away from other people. Think about animals as well, because horses don't like drones. When they're above them, it's okay, because I don't know if you know, a horse can't look up. You're all right, but if they see a drone in their peripheral vision, I mean, I know some horses are spooked by a plastic bag in a tree. So thinking about flying around horses is horrendous. Just be aware of that. But if you go into a local area of parkland, moorland, and there is no restriction in terms of there being signage out stay 50 meters away from everybody, no problem whatsoever. Get yourself some insurance just in case, because the accidents do happen. Prior to getting any qualification, if you go onto the British, I think you'll have it, the British Model Flyers Association, Eleanor, they have a great 30 quid a year. You join and you get £1 million worth of cover just in case. But yeah, you're able to fly in public spaces where there aren't any people around. Middle of a football pitch, nobody there, nobody walking dogs, not harming. Use a common sense approach. People come, put the thing on the ground, let them go past and go and have some fun.
I've added a couple of other companies that provide drone insurance too. How do clients select drone operators? Is there an approved register? So I'll start with that briefly. On the ARPAS website, we do have a find a member map, so you can certainly find somebody local to you. Obviously, it will depend on what you want to do as to and what skills that they offer. Michael can talk you through exactly what you need to be asking them for to ensure that you're getting the right person.
Yeah, it's just like with anything, isn't it? You know, you look at somebody on a trustatrader.com. We're not on that yet, but you know, it's like asking for some recommendations, asking for their experience, asking for risk assessments and method statements. So, are they competent and able to provide that? And you know, it's just like the normal stuff. You get an idea if somebody is able to produce the work. Have they done it in the past? What's the type of work that you want? And you get what you pay for. It's just like any other industry. I think, you know, just be careful about the people who haven't been operating long. Not saying they can't do it, not saying that they won't be able to do it, but just you know, if you were thinking about trusting a builder with your house, I would go to that level of thinking about the drone operator. Is it something that you're going to be asking, you know, you're asking somebody to put a whirligig up in your back garden to hang your washing out, or are you actually asking somebody to go and put a new roof on your house? It's that level of competence and interrogation of them, just to say, can you do it? Are you insured to do it? Have you got any recommendations? And go from there. But the ARPAS website is, people who know what they're doing will be on that website, so it's a good place to start.
Who is responsible for gaining permissions? Can that be a protracted task with lots of red tape?
Yes, it can, and you are, as the owner and pilot, eventually, as the pilot of an operation, you are responsible for your flying. If that flying is over land where you need permission to do so, then it is your place to do so. Quite often in larger organisations, you'll have somebody like me sat in an office doing all the ringing round, like I have been this morning with prisons and airspace in Doncaster, because one of our pilots is flying just north of the airfield. But it is ultimately the pilot's responsibility. It becomes less onerous as you've done it longer. You know who to speak to and how to speak to them. It will become very onerous if you don't speak to the right people. The guidelines will be there in any training, tell you who you've got to. Don't try cutting corners. People say you can't. You can fly over network rail land if you're more than 50 meters away. It's a lot easier to speak to them and say, I'm going to be flying here. Is that okay? And them saying yes, than it is to cause a problem and trains being stopped, etc., etc. So yes, it can be onerous if you don't know what you're doing. If you've got some experience or you've done the right training, make sure you tick every box that you've been asked to tick prior to flying.
That actually neatly ties into a comment from Steve, which is obviously you need to avoid flight restricted zones around airfields and airports unless there is coordination permission from the airfield/airport air traffic services, which is a very valid point indeed. Okay, I think that's it in terms of questions. Let me just check the chat because we occasionally get people who pop a question in there. Let me just double check. No, I think we are okay there. So thank you very much indeed, Michael. That was a very informative, very good first look at what you need to be thinking about with drones, what they can offer you, the advantages as well. So thank you very much indeed. Thank you also to our attendees for coming along today and giving up your, well, sort of potentially your lunch hour to listen into this. If you need to contact us, again, I will just pop Michael's email address into the mine as well. There are a few more CPD sessions later on this afternoon. There's one on control, one tomorrow afternoon on thermal imagery and how drones can be used to monitor heat loss, and excellent CPD sessions. And next week we will be looking at the drone insurance. Necessary evil, I think, is the answer, but an extremely useful one. The industry has a very good reputation, a very safe reputation, and we want it to stay that way. And our final CPD session will be next Thursday, led by Graham Brown on various drone applications as well. So if you've listened to this one, that one in turn might well be useful. Thank you very much indeed, and I shall finish the session now. Thank you very much then, everyone. Goodbye.
Cheers.
One last thing, we will be, sorry, I forgot to mention, we will be posting this on the ARPAS-UK website, so if there's anything you want to go over, find any further details, it will be there and you can watch again. Okay, thank you very much then. Bye-bye.